Hi guys, in this video we're going to be looking at two independent random variables from which we have a few observations to work with. Okay, and I've kind of set this up this way to kind of illustrate some of the concepts that you may be learning about linear transformations and linear combinations of random variables. So here's the mean of x1, the mean of x2. The variance of x1, variance of x2. As you can see, they're very similar. In fact, if we were to compare them a little bit, the mean of x2 is just slightly higher, and the variance of x1 is slightly higher than x2. All right, so very similar and independent. I've tried to set it up that way. Now we can look at one linear transformation, and one linear combination. And what we're really interested in is the mean and variance of these new variables. Okay, so call this y1 if you like, and this second one y2. y2 is a linear combination, y1 is a linear transformation. Okay, and my question to you is, which of these will have a larger variance, more variability? Which one of these? I calculated the actual values by just doing 2 times every x1 value for this, as it says it should be. And for this guy, I just calculated by adding up x1 and x2. Now, we're told, in theory, we're told that the mean of y1 should be 2 times the mean of x1. So 2 times this value. So we expect about 27 here. We're told that the mean of y2 should be the mean of x1 plus the mean of x2. So we expect something like 27.2, right? Here. Okay? So these two random variables that we're creating here based on these guys are going to have more or less the same mean value, right? So it really comes down to what's the variance of these two, and which do you think will have more variance? Hopefully this will build up a little appreciation for the difference between these two. Here we're taking one random thing and doubling it. Here we're taking two random things and adding them. It seems to me when you take more than one random thing and add it up, it's going to have less variability than when you take one random thing and double it. Okay? If you want to, let me try that. Let me try to explain that again, maybe to build up an intuition. If 15 people are showing up at a room, to a room, and you're interested in measuring their height, you're going to get a lot of different measurements. For every 15 people that come, you're going to get a slightly different measurement, right? But imagine instead you had one person show up and you multiplied that person's weight by that person's height by 15. I think that would give you much more volatile results as opposed to 15 people individual weights added up, although that itself will be uncertain and variable. Taking one person's height and multiplying it by 15 will sometimes give you very large numbers, sometimes very small numbers. Very small, very large, right? As opposed to 15 people will kind of even each other out and produce variable results for sure, but a lot less so than the one person's weight and height. Okay? Let's see this in action with just two. Okay? So, the variance of a linear transformation. Let's do for y1. We know it's the variable part, which is just 2. squared times the variance of x1. So this is just 4 times, if we just borrow the sample variance here, 31.6, that's what we would expect. So something like 125 or so, right, give or take, for the variance of doubling x1. How about the variance of y2, which is very similar, except we're summing 2 random variables. So that is equal to, well, you could imagine a little 1 in front of these guys, right? So that's equal to the 1 squared times the variance of x1 plus 1 squared times, sorry, that was variance, of the variance of x2. So here, look, we're adding up 2 variances, and we could borrow these numbers here. So we have 31.6 and 26.5. We have something like 5758, I think, right? Wow, this is dramatically larger than this, right? Kind of like that example with 15 people showing up to a room and we're measuring their heights. The total height we get from 15 people is going to be a lot less variable than if just one person shows up randomly and we take that person's height and multiply it by 15. Okay? So let's just confirm all this by using some functions in Excel to calculate this stuff the long way. In fact, that was the average. Those were the 2 averages that we expected to get. Okay? And as far as the variances go, we can use the sample variance function here. And in fact, we do get this very large variance here. And I could drag this over. And so this is pretty much exactly what we expected using our formulas we learned here. Okay? That we were doing here. Okay? I seem to have lost my ability to write here. But in good time, we learned that multiplying a random variable by 2 produces a lot more variability than summing up 2 random variables that have about the same variance. Okay? So I hope this was helpful to at least to augment some of the textbook examples you may be encountering. Alright? Till next time, subscribe. Make sure to watch the previous video if this was a little bit over your head as a build-up. And comment. Till next time, have a great day.